Good morning one and all. Today I am discussing about fluid mechanics and hydraulic machines laboratory 18CVL48 for 4th semester students under calibration of rectangular notch to find coefficient of discharge in module 1 laboratory class series 3. So the content is to determine the coefficient of discharge through rectangular notch. So the apparatus is rectangular notch, collection tank, constant and water supply, measuring scale and the stopper. This is your rectangular notch fixing location. So this is a cross-sectional elevation of a line diagram of rectangular notch assembly, where this is inlet flow, constant and water supply, a regulating valve and buffer valve flow takes place, gauge well, and this is the head at which flow of water occurs, and this is the measuring tank where piezometer where we can measure the rise in water at a constant time interval. A rectangular notch is a thin metallic plate across the opening so that the water flow over it with a free surface. So a rectangular notch is used to measure the discharge of an open channel. The formulas which are used for this purpose is, first we should understand what we are going to determine from this rectangular notch experiment. The thing is, we will going to calculate coefficient of discharge CD. Next question is how to find CD. CD is determined by using actual discharge through that rectangular notch divided by theoretically estimated discharge through that rectangular notch having a length capital L. That's all the formula that we have to remember. So the actual discharge is Q is equal to, so A into H divided by T, where A is cross-sectional area of the tank in which water is collected, and H is the height of water stored at any time interval T seconds, which is given by meter cube per second, the discharge value. Coming to the theoretical discharge is given by formula 2/3 of capital L into root of 2G into H whole to the power 3 by 2, where L is the length of the crust of your rectangular notch and H is the height of water storage. So in your rectangular, that is this height H1 up to here water flows means here H2 minus H1 will be your H. It is in meter cube per second, and substituting Q actual by Q theoretical will get coefficient of discharge. The procedure is step 1. So I think I will put this. So step 1 is measure the length of a rectangular notch L. Next, here we have a open supply of water, valve will be given, so that valve will rotate it. For that is trials we have to do it. First trial is 25% opening of the valve and calculating how much water will flows here, and it collects in this tank at a constant time interval how much rise in water takes place, or to get this particular rise, for example 10 mm, how much time it takes, that we have to calculate it. Next, the valve will be opened 50% again, so the time taken to reach the 10 mm height in the water level in this tank, we have to measure it. Third trial 75%. Fourth trial valve should be open 100%, so that how much time taken to raise the water in this measuring tank we have to measure it. Okay, so there is a very simple experiment. We have to do it in a 4 steps. Coming to the calculation part, as I said earlier, we have to measure the length of the crust L, and dimension of the tank we have to measure it L into B. From that area we will get it. Height of water storage we have kept it as constant. Some places time will be kept constant and height will be calculated. What is the high rise in height? So by using piezometer, any method we can do it. It will be one and the same. The Q actual is equal to AH by T. I given one example to calculate that value. So 0.174 into 10 mm, 0.01 divided by 36.5. So whatever it is, the value is there that you calculate it. Okay, so that will give Q actual. Similarly, Q theoretical also you can calculate it afterwards. So we will get CD for 4 cases. Take the average of CD value. So next is, it can also be determined by using graphical method. By Q theoretical on x-axis, by Q actual on y-axis, you plot it by taking an ordinary graph sheet, by considering one, that is 2 unit, that means 2 centimeter is equal to 1 into 10 to the power of minus 4 meter cube per second on both x and y axis. You will get a equal area method. If you plot those 4 points, you will get a no line or straight line. The slope of that line, if you calculate it, that will give CD. So the CD theoretical calculated and CD, that is analytically calculated CD and graphically calculated CD may not be one and the same, because analytically calculated CD will have some assumptions in that formula, whereas the graphically calculated CD, we are done some approximation for fixing the best fit curve. Therefore, some variations will be there that we have to accept it. So results, the coefficient of discharge for rectangular notch is theoretically 0.53, or analytical method it is 0.53, whereas graphical method 0.64. Coming to the multiple choice questions, the actual discharge for calculating CD using rectangular notch is given by Q actual is equal to AH divided by T meter cube per second. Whether it is true formula or formula is false is the question, though it is true. Next, second question, actual discharge of for calculating CD using rectangular notch is given by AT divided by H, that is B, false. Theoretical discharge for calculating CD using rectangular notch is given by Q theoretical is 3 by 2 L into 2 root of 2G into H whole to the power of 3 by 2 meter cube per second. So it is false. Fourth one, the theoretical discharge is given by formula they are given, it is false because 4 by 3 is there, it is false. Next, the fifth one, theoretical discharge for CD is given 2 by 5 L whole to the power of root 2G H whole to the power 3 by 2, it is also false, 2 by 5 is there. Next, the theoretical discharge for rectangular notch, CD for rectangular notch is given by 2/3 of L into root of 2G H whole to the power of 5 by 2. So that is 2 by 3 here whole to the power of 5 by 2 is there, is also false. And next is the Q ultimate is 2/3 of L root T, 7 by 2 is here H whole to the power, that is also false. Theoretical discharge for CD with rectangular notch is 2/3 of L into root 2G H whole 3 by 2, it is correct. A. Coefficient of discharge for calculating CD with rectangular notch is Q actual by Q theoretical, is A. Coefficient of discharge for CD with rectangular notch Q theoretical Q actual formula, it is false. B. So these are the list of books and laboratory photos from GSK Information Technical Engineering Bangalore 1. The photos we are actual photos we are used in this PT presentation, and I take this opportunity to thank Department of Collegiate and Technical Education for giving me an opportunity to deliver laboratory class LMS lecture for fluid mechanics and hydraulic machineries, and I thank all the students for attending the class. If you have any doubt, you can ask it in the next class. Thank you.